In 7D, we start working with Venn diagrams. I really like the Venn diagrams because it gives you a visual of how these sets interact with each other. So, you guys have worked with Venn diagrams most likely, definitely, in other courses. Now our Venn diagrams are going to have lots of different looks to them, not just your traditional two circles every single time. So, in a Venn diagram, the universal set is represented by a rectangle. And then the sets within are going to be circles. That's just your standard way of making a Venn diagram. So we start with a universal set. And then within that we will have subsets. So we'll make this an example here. We're going to put together a Venn diagram for the information that I give you here. So U is our universal set. Let's make that 1, 3, 5, 7, 9, and 11. We will represent A as the set 1, 5, 9. Okay, so let's put that information into a Venn diagram. So our universal set is all of these numbers. So these numbers should all be in our box, but these three need to be grouped together as A. So I'm going to write those first. So I'm going to put my A in here. A. And those three numbers need to be in A. They're also in the universal set. So my whole A circle is within our universal box. The numbers that need to be outside of A are the ones that aren't here, but they are here. So 3, we already got 5, 7, and 11. So this Venn diagram represents these sets. Our universal set's the whole box. It has all 6 numbers that are listed here within that box. These 3 are grouped together because they're part of A. The 3 over here these 3 would be a complement. Those are the ones that are in U, but not within A. Okay, let's add some more sets to our Venn diagram. So let's do our universal set. Let's leave it the same as it was above. This time I'm going to give you A, and I'm also going to give you B. So let's make A 1, 3, 5, and let's make B 5, 7, 11. So we want to represent this information on a Venn diagram. So we're going to start with our universal box. And within this box, we will need to have all of the numbers that are in our universal set. We don't want to just write them because some of them need to be grouped together. So within A, we need to put 1, 3, and 5. So I'll put A in here somewhere. Now I'm noticing that 5 is in both of these, so I'm going to kind of put it on the edge. So this is A. A contains 1, 3, and 5. Whenever I go to put B, I don't write 5 again. 5's already in my universal box, but 5 also needs to be in B. So this is where your Venn diagram starts to overlap. 5 needs to be in the universal set, so it's in the box. It needs to be in A, and it also needs to be in B. So they overlap at 5. 7 and 11 are only in B, so they don't need to be in the A circle. And then we need to check to see if there's any numbers that aren't represented. So 1, 3, 5, 7. So 9 is not in A or B, but it is in the universal set, so it needs to be represented in the universal box. So this information will look like that on a Venn diagram. Now, visually, we can start to pick out different pieces. So if we did A intersect B, Intersection means that it's all numbers that are in both A and in B. They have to be in both of these. In our Venn diagram, the place where the intersection shows up is where they overlap. So the number that A and B both have is 5, and in our Venn diagram, that is right where the circles overlap. So within our circles, the intersection is what they share, their overlapping piece. In this case, it's 5. That's the number that's in both A and in B. For the union is all numbers that are in either A or in B. So they could show up in A or B. They could show up in both. That would be fine, but they have to be in one or the other. So visually, in our Venn diagram, if they need to be in A or B, or maybe both, then it's these are in A, these are in B, that's in both, so it's all of this. 9 is not used because it's not in A or B. It's not in, it has to be in at least one of these to be in the union, and it's not. So visually, with our Venn diagram, the union is all of the numbers that are in the whole thing, okay? They're in A, they're in B, maybe they're in both, they're in that whole set of circles. So in this case, it's 1, 3, 5, 7, and 11 for our union. Okay. All right, I'm going to do one more example of our Venn diagrams. Let's see. Mix it up. Let's use letters. So our universal sets A, B, C, D, E, F, and G. Let's make set A be A and B and C and D. And set B is going to be F and G. So we're going to represent this information in a Venn diagram and then ask a couple questions about it. So we have our universal box. All of these letters have to be represented in the universal box. And we need to strategically group them. So I'm going to start with A. I'm going to look at A and B and see if they have anything in common, because I'll need to make sure to kind of arrange them so that it could be in both. So A, B, C, D, F, G. So they don't have anything in common. A and B are what we call disjoint. Okay? They have no elements in common. Okay? They are disjoint. They have no common elements. So whenever I draw my A circle here, and I put A, B, C, and D in it, my B circle doesn't need to overlap A at all because they don't have any common elements. So F and G are in the B set. A and B don't share anything, so they don't need to share any space. They're disjoint. They have no common elements. And then I think there's a letter missing. E needs to be in the universal set, but it's not in A and it's also not in B. So let's ask a couple questions about this. So first, let's do A intersect B. So A intersect B, if you look at the last page, was the stuff that they had in common, where they overlap. In this case, A and B aren't overlapping at all. They have no common elements. So the intersection is empty. So you can do this, where you just put squiggles, or like this means empty set. That would be fine as well. I think the textbook uses both, like here and there, but it's empty. They have no common elements. Okay. Now the union, that's not the case. The union is all elements that are in A or in B, either one is fine, or maybe both. So for this, elements in A or in B, so A, B, C, and D, F, and G. Okay, so all of these and those go here. So they don't overlap, we just do all the elements in A and all the elements in B, they're in the union. So graphically, for that, it's everything here and everything there, okay, in both. A complement indicates all elements that are not in A but are in U. So not in A, so they're not here, but they are in U. So this is A, we're going to pick everything that's not in that. So E, F, and G are not in A. So visually, if you have A here, we pick everything outside of A to be the complement of A. It's everything that's not in A. Alright, this is an introduction to Venn diagrams. There are Venn diagram questions that pop up on the IB exam here and there, and we'll use this more as we dive into probability and some different things. So, thanks for watching.